All right, guys, I think let's get started. Guys, from our side, we just wanted to say a very warm welcome and thank you for joining our first webinar for 2023 already. Can't believe, and January is already kind of out of the window. So from our side, once again, a very, very warm welcome. So ultimately, I just would like to start off this session just to basically just go through some house rules. So if I can just make a request, can you guys just make sure that you mute yourselves? There will be a question and answer session at the end where you're more than welcome to either then basically participate verbally or via the chat box. The chat box is being manned by Sean Dane, our segment manager, so he's basically on standby there. As I've mentioned, the session is recorded. And also, guys, please just make sure that you keep your video switched off during the course of the session. Okay, that basically concludes the house rules. Now we're just going to move over to the agenda. So the agenda that we'll be covering today is I'll start off with just some introductions on my side and also with Conrad. And then we'll move over to just a quick overview of the previous webinar that took place on the 10th of November last year, where we gave an overview of the Mavic 3 Enterprise series drone. Then we're going to move over to TVC, the aerial photogrammetry module, processing the actual DJI Mavic 3 Enterprise data. We've got a specific use case that we'll be covering today, so we're going to then hone and basically discuss the use case that we'll be covering, and then also deliverables and data sharing, and then also just some tips on making sure that you're getting the best out of your drone, making sure that you keep your batteries healthy and safe. So yeah, we'll just basically go through some tips and tricks on that. Okay, and then lastly, we'll end off with a Q&A session. So if you have any questions, please feel free to just put them down on the chat box. As I've mentioned, we've got some Optron guys that will be attending to that, and we'll attend those questions also during the Q&A session. Right. So just as an introduction, so for the guys who might not know me, I'm Gustav Fick. I'm basically the subject matter expert for UAVs and scanning at Optron. And ultimately, I'm responsible for managing the UAV products and also focus a little bit more on the solution of how do you take your drone, and then ultimately, how do you actually kind of put it into play. So that's basically in a nutshell. I've started with, in 2011, I've actually started as an engineering surveyor after my studies at Reed & Partners, then joined Optron from 2014 as an application engineer, and then as I've mentioned, now occupying the position of subject matter expert for UAV and scanning. It also gives me great pleasure to also introduce Conrad Klopper today. For those who might not be familiar, or I'm pretty sure a lot of you guys have dealt with Conrad. He is serving at our help desk. So Conrad, ultimately, he's our dedicated pilot when it comes to flying these drones and getting also on the training aspect, making sure that if you invest in our equipment, ultimately you'll definitely be dealing a lot with Conrad from a training perspective. So Conrad, a very warm welcome to you and thank you for joining me today.
Thank you very much, Gustav, and welcome to everyone, and thanks for joining us. I hope you guys have some fun with this.
Excellent. Thank you, Conrad. Guys, then just a quick summary on Optron. So we've been around, we've been established since in 1986. Our brands, our OEMs have exponentially expanded. We started off with Trimble, but these days we've got various OEMs that we basically supply, and we distribute the products through Sub-Saharan Africa. But the products that we will be focusing today is on DJI and on Trimble. And also just to give you guys an idea of where we as Optron stand today. So we've got 5 regional offices. We've got a dedicated help desk that basically is on standby for your technical, in your pressing challenges that you might face in the field, and then also we've got a dedicated service, certified service center that to actually repair the products that we basically supply. Okay, that's basically Optron in a nutshell. I'm now just going to focus on the Mavic 3 Enterprise drone. Just a quick overview. I'm not going to focus too much on the technical specification side of things, but this is purely just an overview for those who might have missed our webinar, or it's the first time that you actually seeing the DJI Mavic 3 Enterprise unit. But the DJI Mavic 3 Enterprise unit is basically now replacing the Phantom 4 RTK. For the guys who have used the Phantom 4 RTK, I'm pretty sure you had a various success out of the UAV, but it's now being replaced with the DJI Mavic 3 Enterprise unit. Conrad, can you just give me a thumbs up if you can hear me okay?
I can hear you okay.
Okay, excellent. All right. All right, but ultimately it comes in the Mavic 3 Enterprise unit. Basically, there's two options. You've got your Mavic 3 Enterprise that will be used for survey and mapping applications, but you also have a thermal option. So if you're into inspections and those kind of applications, there is a dedicated unit for that. Then it's got a mechanical shutter, so that will basically reduce, while you don't have that rolling effect on your ortho photos that you basically generate. And also the camera is being calibrated when it's basically produced. All right, so all the internal parameters is then written into the image itself. It's also got a portable design. Sorry guys, sorry about that. Okay, so it's got a portable design, and it also, it's got a 45-minute flying time. So you'll see that there's quite a lot of enhancements that actually went into this product. And then also the weight, it only weighs 915 grams. Okay, let's just focus on the camera a little bit. So you've got two cameras. You've got your wide camera and you've got your tele camera. The wide camera is ultimately the one that you would use for the survey and mapping applications. Then it's got a 20 megapixel camera, and also your tele camera, which can be used for visual inspections. There you will see it's got a 12 megapixel camera and a 56 times hybrid zoom. Next up is but we're going to focus on the improved surveying efficiency. So as I've mentioned, so your improved flying time compared to the Phantom 4 RTK, and I'll do some comparisons after this slide, but it's got an improved flying time. The shutter speed is also improved. The maximum speed has been improved to 15 meters per second, and then you've got the ability, and also depending on the flying height, of course, but you've got the potential to map out a 200 hectare area in a single flight. Once again, it all depends on your flying height, and but yeah, I just wanted to basically give you a quick overview of where you would gain on this on the Mavic 3 Enterprise unit. Also, if you use a charging up with a different with your battery kit, you can get up to 70 minutes of flying time, and then ultimately you can make sure that you will be able to cover the whole days of flying. So guys, I also just wanted to quickly just focus on, so ultimately what's in the box, the standard package. So there's just a quick, just basically all the components that makes up this Mavic 3 standard package. So you've got the aircraft, you've got the battery, and then also you've got the optional components, which is the RTK and PPK module. You've got a speaker option that you can also add onto the Mavic 3 Enterprise unit. And then also the other optional part is also a battery set. See this as it's almost like a fly more kit where you can now have 3 batteries with charging up to charge your batteries. But ultimately, guys, this is just some of the components, so the standard package and then also the optional accessories that you can add to your Mavic 3 Enterprise unit. Okay, then to focus a little bit on, as I've mentioned, the Mavic 3 Enterprise unit replaces the Phantom 4 RTK unit. What I've done here is basically just to highlight some of the key components that has actually improved the technology. Once again, is the weight. So it weighs less. It's more portable. It can fold up, where with the Phantom 4 RTK that wasn't the case. You've got improved wind speed resistance. You've got improved flying time, as I've mentioned. You also have an improved flying speed for your mapping missions. Then also you've got a better CMOS camera sensor that's also been improved. The other thing is also, as I've mentioned, on the telecamera, where you can actually now, with that 56 times hybrid optical zoom, that is ultimately, you didn't have that option with the Phantom 4 RTK. So if you need to do some visual inspections, this is now possible with the Mavic 3 Enterprise unit. And then also, just in the summary, and basically just to conclude this, is just that you can add on the speaker component. This is now, if you need to do some public management, when there's, it's actually being used, if there's riots, for example, but this is purely just a completely different application, but I'm just basically mentioning that so that what is the reason for the speakers. We literally, and also for search and rescue applications, where you literally need to give communications through to the person that is in need. All right, and then the 4G image transmission is now supported, and also HDMI capabilities, where you can plug in and then basically show what's happening on your controller on an external screen. Once again, if you're doing inspections, that is quite a nice feature to use. Okay, guys, that basically concludes the Mavic 3 Enterprise specifications. I'm now going to move over to Trimble Business Center. So Trimble Business Center, the role that it plays is basically that Trimble Business Center is now where you would take your data and actually create your deliverables. So TBC is basically seen as the geospatial data hub. This is where you would now take your hardware components, the data that you've captured, you'll import your data, and as you can see, there's various types of sensors that you can now import the data into TBC, anything from your typical Trimble GNSS receivers, your robotic total stations, your normal total stations, your digital levels, your 3D laser scanners. All that data can now seamlessly feed into Trimble Business Center. So it doesn't matter what exactly did you use on your project. You can now import all of your data, and including drones, of course, is where you can take the data, feed it into TBC, create your deliverables, and then share it with your clients. Also, your third-party hardware the data can also be fed into TBC, as you can see, just to mention some of them. And then also sharing the data with other software packages. As you can see, typically with Bentley, ArcGIS, TopoDot, etc., all the data that that's in your project, that data can now be shared with your preferred third-party software package. Okay, just some of the unique TBC values is that you can basically capture your data and process your data with confidence. There's data integration where there's streamlined workflows on how to actually take your data and creating those deliverables. And that's ultimately what we as Optron, what we do, we consultants, and ultimately we want to make sure that you get the best out of your hardware and get to your deliverables faster. And then also, well, as I've mentioned, just to add to the deliverables, is that the software allows for you to offer more. So the rich deliverables, I'm going to touch on that in more detail, but ultimately it's just giving your client a better experience on working with data, especially not just a typical 2D plan. You can now start sharing 3D data, and there's various other platforms that you can actually now use to do exactly that. Then the interoperability is the seamless transfer of your data between your enterprise software. So as I've mentioned, it doesn't really matter in terms of it, taking the data. If you've got another third-party software, for instance, if you need to model your data, to get the data into Recap or Revit, just to name a couple of options, is that is basically that can be done. Okay, just to focus on, so what can TBC actually do? So it is a CAD and drafting package where you can actually create your deliverables in terms of taking your data, putting it onto a title block, and then submitting the 2D plan. That can be done. So it's a CAD software package as well. You can compute your surfaces. You can, from your surfaces, then calculate your volumes, for your typical stockpiles and also mining applications. Corridors, if you're into, you're working for a construction company and you need to do road designs and also stake out roads, you can do all of that in the corridors tab. Then data prep. Data prep is quite unique. Data prep is where you can literally take your PDF document. If you have, let's say for instance, your contour lines, you can take those contour lines, select them, and basically digitalize them, where you can actually now appreciate the data with the values of the contour lines, for example, where you can actually have that 3D aspect. And that's actually a very nice tool, especially when you need to do designs and those kind of things. Let's say typically you need to do earthworks. That is quite a nice feature to use. Point clouds, working with point clouds, not a problem at all. Tunneling and monitoring. So for instance, if you need to calculate the underbreak and overbreak, and this is more applicable for the guys that's working at the underground mine, for instance, there is ways where you can take the data and then basically do your calculations on that. Your conventional survey field data that can seamlessly import, as I've mentioned, and then also adjustment in COGOs, creating reports, all those things. And that basically brings me to my next slide, creating those rich deliverables, where you, as I've mentioned, I've basically touched on most of these points already, but this is just to show you what is possible in the software, what you can generate, how you can share the data with your client. Guys, I'm going to focus, as I've mentioned, this is basically utilizing the DJI Mavic 3 Enterprise unit, feeding it into TBC. As I've mentioned to you, this is purely also to give you an idea for those who are very new to drones and you haven't actually processed the data yourself. I would just like to assure you that there is dedicated workflows, and Trimble has spent a lot of time actually streamlining this process, making it simple. Press the button on this side. It's quick and easy 3-step process to actually get your data and actually generate that deliverable. So this is just to give you an idea, and I'm going to touch on this when I'm actually now done with the presentation, where I'm going to move and just give you guys a feel of what can you expect out of TBC. Then also the flow diagram. What's important about this flow diagram is that you've got options. Depending on how you're planning to embark on your project, if you're doing with your Mavic 3 Enterprise unit, if you're using the DRTK2 base station, that is a base station that is dedicated to the DJI Enterprise drones. So this is ultimately allowing you to capture RTK data of your photo station positions basically in the field. And typically if you're using that, if you basically did the data capturing with the DRTK2 base station, ultimately what you would do, you'd start off with the RTK drone with high precision GNSS solution, and you will just follow this diagram to just ultimately get to your final deliverable, which would be a orthomosaic image or a point cloud or both. But ultimately this is just to assure you that it's tried, it's tested, and we can literally just basically share this with you to basically get you up and running. As I've mentioned, you can now complete your deliverables. This is just a quick some examples of what you can actually do with TBC. It's a very unique workflow on taking your data and then plotting this depending on what your deliverable would be, but this is possible to do in TBC. And I'm just sharing some examples with you guys. Okay, then when it comes to the data sharing side of things, is that through TBC, you can create a project in a web browser that is called Trimble Clarity. So for instance, if you're sharing your data, you've got this absolutely beautiful point cloud data set, and now you're giving the data over as a 2D plan, basically, a detailed contour plan, for instance. You know, that kind of takes the appreciation of the data out of things. I mean, yes, that is what we used to do, but how do you improve your service delivery to your clients? And this is now where a platform like this can come into play. This is where you would take your 3D data, upload it as a project, and then your client, which in most cases don't have 3D software to actually appreciate the data. So he can now follow the link, basically go and explore this project. As you can see, there's just some of the industry standard file formats that you can now upload, and then your client can now interact with that data and appreciate the data to ultimately get the bigger picture. Okay, that basically concludes just the overview of Trimble Business Center, and we're going to now jump over to the use case where we've actually went and we've put the Mavic 3 Enterprise series to, we've basically pushed the boundaries ultimately in this specific use case. So ultimately, let's get started. So just to give you guys a little bit of background here, so this basically took place about 2 weeks ago, where a client of ours, Regumatics, we basically, there was an opportunity. They were assigned as the land surveyors to go and do a topography survey of the areas that is basically marked in red there. And this was ultimately what they needed to do with the data was to now calculate the flood lines for that specific area. So I also want to just use this opportunity to just thank Henny Susan, Malaza, and Co. Just wanted to thank you for really kind of, thank you for this opportunity. Thank you that we can actually, this was a great use case where we could actually go use the system, and you guys really helped us a lot with building of the ground control points. But yeah, ultimately, so this was an absolute team effort, and that's ultimately just to give you guys the background of this use case. So then what we did was we accepted the challenge. We went to the site, and on arrival, we noticed a couple of things. Firstly was that it was quite a challenging site. It's got long grass, which is challenging for photogrammetry applications. So we knew from the get-go that this is going to be a challenge. But ultimately, as we wanted to push the limits ultimately. So we embarked on this challenge. We used various drones, but for this specific webinar, we're only going to focus on the Mavic 3 Enterprise data sets. But we went in, as I've mentioned, we noticed that, tall grass, that will ultimately affect the generated digital terrain model. The area is also fairly flat. So we didn't use the terrain following feature. And then also just some of the other stuff that we've identified is that we've basically assigned a flight squad, which was Conrad as the pilot. I'm basically fulfilling the role as the observer. And then also making sure that, identify where are we going to do our takeoffs with the drones. That was purely just to make sure that we get ourselves ready for success on this mission. So Conrad, maybe just to quickly hand over to you the terrain following feature, maybe if you can just just briefly just touch on that? Where would you use that? I know you've used it on a couple of specific scenarios. Can I maybe just ask you just to give you a quick overview on that, please?
Yes, so terrain following, it's quite effective. I've used it with the Matrice 300 RTK. We used it in George with, it was very mountainous terrain, and to do the terrain following, you just need to obtain a DSM, digital surface model. You basically then pull it into your flight planning, into the DJI planning software pilot, and then you can choose your height that you stay above the terrain. So it actually follows the terrain as you go. So especially in George, where they actually farming up into the mountains now because of space, and then that's a good application for that. Works very well.
Fantastic. Yeah, thanks for that brief overview there, Conrad. Much
No
appreciated.
problem.
Okay, so ultimately what we did was we knew the boundaries that we need to cover. So what we did was, as I've mentioned, we used various drones for this specific project because ultimately doing some testing and also putting the drones to the limit. That was ultimately the idea here. So what we did was we're going to focus on the white blocks in this specific webinar. That is where we've then now used the DJI Mavic 3 Enterprise drone. So that is, as you can see there, we've basically identified where do we want to place the ground control points. This was now shared with Regeomatics, and they actually went out and they staked these positions out. This was, all the planning part was done in TBC. They went out and they really kind of just exceeded all expectations. We've made sure that, you know, they are comfortable and experienced as they are. They went out, they placed those GCPs for us and also built the ground control points for us. As you can see there on the bottom left-hand side, that is just to give you an idea of how the GCPs look like. The challenge on hand is that we couldn't use physical markers, okay, purely just because it being in a challenging area, that we didn't want to take the risk of, you know, the ground control points or the markers being stolen. So ultimately we just decided this is how we're going to do it, and it actually worked out pretty well. Okay, then what we did was, this is actually the solution that we used. So that was the DJI Mavic 3 Enterprise unit. We used Regeomatics used their Trimble R2 and Trimble R4 Model 3 base and rover systems with Trimble Access Field software to now do the surveys and also measure out the ground control points for us. And also, just to let you guys know, they actually surveyed that whole area as well. So we didn't only fly it, and ultimately that was the idea, is to do that and then run a couple of comparisons in a challenging site. Then what we did in the field, it being a very challenging week with between stage 6 and stage 8 load shedding, we really didn't want to take the risk of you know, especially with the number of flights that we want to do. We made sure that we've got a generator as a backup in the field. And then ultimately, this is just to give you an idea of how we basically used it, is literally charging all the batteries with the Mavic 3 Enterprise batteries. What you can see there is the BS60 battery station. That is ultimately for the M300 RTK. And then we've used Trimble Business Center for the data processing. So just to give you guys an idea of what we've used on this project. Okay, just an overview of the data capturing side of things. So for both flight missions, it was fairly the same size. So we did 2 flights for both of these flight missions, and it worked quite well. And so I'm going to elaborate on this just now. So ultimately what we did 2 flight missions. You'll see that the total flight time was 32 minutes. So what we did here was we'll do the first flight with the Mavic 3 Enterprise, and then as soon as the battery usage comes down to 30%, we will finish up the line. We'll bring the Mavic 3 Enterprise drone back. We'll replace the battery. And with DJI Pilot 2, it's quite a seamless process. So all that you do, you literally just basically continue with your mission, and it will go and it knows exactly where it needs to start again. So once again, we just applied some simple safety principles during this mission. But there you can see the total flight time was 32 minutes, for flight mission 1 and for flight mission 2. The areas that was covered was about 40 hectares for both. The number of photos, once again, you'll see that it was very much the same. Total file size, this is the raw data of all the images, came down to just under 8 gigs. The flying height that we maintained or tried to maintain over this project was about 80 meters. And then the percentage overlap was about 70-70. That is what we used. And also the ground sampling distance that was selected on the specific height was about 2.1 centimeter per pixel. That is basically, this was what we captured and we tried to achieve during the data capturing process. Here you can get an idea on the right hand side of the vehicle that we've used. We've basically made sure that, that Conrad is basically kind of in a nice and a cool place, and basically for us to get the mission sorted out. Next part was on the data processing side of things in TBC. So this is just to give you an idea of your data preparation for flight mission 1 and 2. The setup of the project, this is ultimately, and I'm going to take you through this process after this presentation, but this is ultimately just loading up your data. Depending on the size, it might take a little bit longer, but this is now to set up your project. The baseline processing step, this is just to give you an indication of how long that process takes, and then also to create your deliverables. Because the areas and the number of photos were very much the same, it was basically kind of the same time that it took to do the data processing for both flight missions. Okay, so what was the conclusion? So as you can see here in this specific image, the areas, the magenta colored areas, because it being quite a difficult site with long grass, those areas were the areas where we had the most success. And what we did was ultimately comparing the data that was generated. The GPS data was ultimately the baseline. All right, so that was typically the positional accuracy that you can get from your GPS receivers. And also, just to come back, because it was quite a challenging site, we focused on the vertical precision because we knew that it was going to become or be challenging for this project. So what we then did was we used that generated point cloud, and there's some nice classification features to remove, for instance, the houses, the trees and high vegetation, those kind of things. There's a feature that you can now run in TBC that does the classification for you to get you down to kind of the ground level. Okay, that is, as I've mentioned, the classification tool. So we've used those points to create a surface, and then what we did was to then basically see what was the differences, and hence also the important aspect here was just it was quite challenging. The long grass, and be aware of that, and that's the reason why we're sharing this. Just be aware of that, so when you're embarking on a challenge or a typical project like that, just be aware that, make sure that you do the necessary checks and put stuff in play to make sure. So for instance, the areas where there was long grass, where we couldn't actually get reliable height values, what you can do is, be aware of that, and then ultimately clip out that section and then replace it with GPS points. So the final conclusion was just that the average vertical variance in those specific areas that we targeted was satisfactory, and the variance between the two surfaces were approximately 3 to 5 centimeters. So it's just important, once again, to know that understand where the limitations is, understand what you need to put in place It being quite a tricky application because it was for floodlines. I mean, it's close to water. There is high vegetation there. So we knew the challenge. We knew the risks. I mean, you could have used other options like maybe a LiDAR payload. But ultimately, we used the Mavic 3 Enterprise purely just to share this with you guys. Then lastly is the deliverable side of things. So the deliverables that was generated was a orthophoto. So the resolution that I've generated here was a medium resolution, which was approximately 60 millimeters per pixel to generate this orthophoto. We generated a point cloud, as you can see there on the right-hand side, and that is now in 3D view. We then use the data to create a 3D surface to now generate contours, and this was all done in TBC. And then lastly, you can take it to create your final deliverable. And me not being the most impressive or the greatest draftsperson, that was just my humble attempt to just basically show you that all of that can take place and basically get completed within TBC. Okay, that basically concludes the presentation part of things. I'm going to hand over a little bit later. I just want to quickly focus on TBC quickly, just to quickly take you through a couple of features within TBC before I hand over to Conrad to just take us through some tips and tricks with DJI batteries. So I'm just going to quickly unshare my screen and then just open up TBC. Conrad, just give me a heads up when you can see my screen.
I will do.
Okay, just bear with me. Screen, there we go. All right, just let me know when you can see my screen there.
I can see your screen there.
Okay, guys, so the first thing is the red flags. So that's ultimately, so as I've mentioned, what we did here was we shared the GCP positions with Reed Geomatics. They went out and they actually looked for a good area where they can basically now measure in the GCPs and then obviously also build them. So hence the reason for it being out of tolerance. So they stake the point out, and that's the nice thing about TBC is that you can perform some QA QC checks as well. When you see this, you have to investigate. Okay, so I'm going to quickly just take you guys through. So first things first is I just want to quickly just switch off. So as you can see on my left-hand side, there's my filter manager. So what I'm going to start off with is just I don't want to see these RTK vectors. I take note of this, but I ultimately want to focus on the flight mission area. So I'm just going to quickly just scroll down. I've basically put these layers in place. You can create these layers as you go along. But for now, I am going to switch off my raw data, which is my RTK vector data. And I'm also going to switch off my points. Okay, so you can assign these to specific layers. As you can see there now, that is basically now hidden. I'm going to switch off my point IDs as well. So here you can see, as I've mentioned to you guys, this was 2 flight missions. So your first step is to now take your 2 flight missions and then merge them. I'm going to quickly take you guys through this process and then also just through the processing the data sets. So if you go click on the photogrammetry tab, just going to switch off my background layer as well. And what you see now is you start with your merging your flight missions. Once they are merged, that is when you would create these solid lines. And there you can see all the photos that was taken. What we did was we used Reed Geomatics, we used their base station to log static data. So what does that mean? So that ultimately means it's storing data to correct the photo station's positions so that your photos are basically more in line and that you've got true positions, typically like RTK positions for your photo stations, and that will improve the processing part of the data. of your UAV data. So what you need to do first is to process your baseline. So you literally basically merge your flight missions. Then you basically move over, you process your baselines, then you will ultimately get this, okay? And then next up is to start with your adjustments. So you'll start with the adjust photo stations. In this process, it basically looks for tie points from your all the various overlaps between your photos, looking for common points. And then next step is to do your ground control points. Where you would now go in, actually snap off to those ground control points. So once you've done that process, then next up is to basically now create your deliverables, which is orthophoto, point cloud, all in one step, or basically if you want to do both, but you basically select what you want to do. Okay, after the photogrammetry part, this is the deliverable that you can get out of that. I'm going to start off with the orthophoto. So I'm going to now just also switch off my contours. My contours are basically there. Okay, it's just loading. So this was the, as I've mentioned, the medium resolution option that that was generated, and you can now just get a good indication of the quality that you can get out of stitching the data together. From the first glance, I was very impressed. You will see that for the guys with some photogrammetry experience, processing drone data, you can see the smooth stitchness, how did it actually stitch the images together. You don't see those weird warping on roofs, for example, or linear objects. So we were very, very impressed with what we actually generated out of this. And as you can see, this can now be used to make some visual better decisions, so that where you can actually now see what's actually happening on site. As you can see there's the road features. I just want to give you guys an idea of the GCPs. So ultimately that was the GCPs that we've used. And so that is now the orthophoto. I am now just going to switch on the point cloud data. So I'm now just going to switch off my georeferenced image. Just bear with me. I'm going to move over to my point cloud data just now. Okay, so that's that. If I go over to my 3D view, you'll see that my CAD, okay, there we go. I just, that CAD for those magenta areas, I didn't drape it to the actual, to the point cloud. I just basically just did a complete, just an elevation for that. You'll see that's why the CAD is not actually on the point cloud, but that is now the point cloud data set. So what you can now do is also with the classification part. So there you can see that's my digital surface model. That's with the roofs. But running a quick feature point clouds classification tool, okay, you can now run this. If you click on this function, this is where you will take your complete point cloud and then just extract what you basically need. If you're only interested in the digital terrain model, for example, you just select ground and you run that process, and then it will then ultimately, what will happen is that you will generate a point cloud. What we also did was we sampled the data set. Ultimately what it means is just reduce the density of the point cloud. So I'm just going to just show you guys this, and this was ultimately used to create a surface and then to generate your contours. Okay, so there we go. So now to show you the surface, so you just activate your surface. And what I would like to show you guys here is just how do you switch on and work with what you need to work with. You can also have multiple screens You can have the 3D view literally in a vertical tab, for example, where you can now literally just work with in whichever view you want to work. So I'm just waiting for that. Okay, the surface is on this side. Let me just switch off my scan data. I might just need to recalculate this quickly for the surface to load in the 3D view. But ultimately, I just wanted to take you guys through that. You'll see the color of the surface that can be changed, guys. It's just a difficult color to see, but you can change this color to any color that you feel necessary. So if we need to change that to green, for example, there we go. All right, so that is just to give you an idea. And then if we switch on the contours again, ultimately, there we go. So that is just to show you the process of generating the deliverables using the photogrammetry tab. And as you can see, there's various other tabs for volume calculations, etc., etc. But this was just the part that I wanted to share with you guys. After the processing, it will give you the reports. So it will basically show you when you do the type point extraction, that is when you do your photo adjustments, it will show you typically what was your type point quality after the processing. There you can now see, you'll see towards the edges it's reduced because of there's not corresponding overlap in that last line, over the images. You'll see that the better the type points were found here in the middle. So it will basically show you during the first step what was the results there. I'm going to just fast track, and this example of this can be shared with you guys if you would like to actually get an idea of the processing of the data. I'm just going to jump over to the GCPs. This is the GCP positions, and then after processing it will show you what the residuals were, what was the accuracy that was obtained. So everything is basically listed in this report. So that basically, in a nutshell, concludes the quick TBC overview. Guys, there is a lot of other stuff that we can show you guys on the software, but ultimately, for the sake of time, I'm just going to hand over to Conrad to just touch on the getting the best out of your batteries, and then we'll open the floor for some questions and answers. So Conrad, over to you. I just want to unshare my screen quickly. Sorry guys, I'm going to just move over to my presentation again from current slide. Okay. And then just share my screen. Bear with me. All right. Conrad, over to you.
Thank you, Gustav. All right, guys. This is just a few tips and tricks to keep your batteries healthy and safe, and also to keep your drone in the air and get the most out of your batteries. So it's very important to read and follow the guidelines in the user manual. As you know, everything comes with a user manual. It's recommended to go through it before you start using it. Batteries of it applies to the M300 now, because it has a BS60 battery box that you can actually also update the box with firmware and update the battery firmwares. Beware of extreme temperatures. Like extreme temperatures are battery's worst enemy. Too cold, too hot, it can affect them in a negative way. And also charge your batteries with an official DJI charger. That is because sometimes if you use a normal or a different charger, it doesn't always charge your battery as it should. So it's also recommended to use the chargers that come with the batteries. And also you need to perform the best practices for battery storage. When it's fully charged, do not store it at 100%, and also avoid draining your battery too much. So ideally to store battery is about 70%. And also keep your batteries in a good environment, not too hot, not too cold, just a controlled environment. And then also do not overcharge over discharge your batteries. That can also do some serious damage to your batteries, and you won't get as long a life out of your batteries. And then also with the M300 RTK and the M200 series, you do need 2 batteries to fly, or you need 2 batteries per flight into the drone. So it's best to keep them in pairs so that you use the same pairs all the time. And then also don't forget to do the maintenance on the batteries. There's also a few insights and things you on the website that you can follow with the maintenance. Then the maintenance procedure is charging and discharging the battery. It ensures that you have an accurate digital readout of the battery percentage, which is very vital to the operation of your drone and effective operation. If this process is ignored, the percentage margin of the error can be amplified if you continue using it like that. So to do the maintenance procedure, it's recommended to do it every 3 months or every 50 cycles. A cycle is basically every time you charge a battery. Then to do that is charge and discharge the batteries per the instructions that will follow, that we can quickly give a brief overview of how to just maintain and go through the maintenance procedures. And then you must make sure the cell voltage difference is less than 0.1 volts after the battery is fully charged and left stationary for 6 hours. Then visual inspections, obvious things that you can see is make sure that the battery is not swollen, leaky or damaged. I'm pretty sure you can see on a battery if something doesn't look normal to you. And then also after every flight, it's recommended to just check the batteries, check the terminals, clean it, and clean it with a dry cloth. Then to charge and discharge the batteries, it's quite simple. It just takes a little bit of time. You can charge the battery to 100% and leave the battery stationary for more than 24 hours. Install the battery into the aircraft, fly the aircraft, and then once the battery level gets to less than 20%, you can remove the battery from the aircraft and leave it stationary for more than 6 hours. Then you can check the cell voltage and you can charge the battery again. And to check the cell voltage is quite easy. You just connected your controller to your drone, put that battery in, and it will actually give you some information on the battery that's in the drone. Common issues to look out for is batteries should be taken out of service and replaced if any of the following occurs. Like I said, you can see visual swelling, leaking or damage, cracks, dents, if there's some melted terminals. Then also bent terminals, which can cause a short circuit and can also then affect your drone. It might fall out of the sky. And then on the app, on the controller, you can look for any notifications that it gives you about your battery, if the cells are damaged or if it's not operating normally. And also when your battery has reached 200 cycles, that's charging cycles, you must take it out of the battery cycles. Then to retire your batteries after about 200 charging cycles is anytime the battery is charged, it counts as a charging cycle. So that's then if you charge it 200 times, you can actually also see that in the app. And to dispose of your batteries properly, it includes discharging the battery fully and then immersing it into salt water for 8 to 12 hours. And then you can also, like I mentioned before, you can go to the DJI website and you can go, there's quite a few things that you can go search on, and you can go and search for DJI Enterprise Battery Maintenance Guide, and they will give you a bit more details on the tips and tricks and how to use your batteries effectively.
All right. Yeah, thank you so much for that, Conrad. Much appreciated. Guys, my apologies. We were slightly over. We're going to open up to some questions and answers now. We're going to just attend to, if you guys have any questions. I see that there was a couple of questions, but I see most of them were attended to. If you feel that your answer or your question wasn't answered, please feel free to ask them again. Sean, I see also Michael is assisting. Guys, I'm just going through the chats. Is there maybe anything that we missed there? I think Talita van Sail. Talita, so if the digital surface model, are you referring to the terrain following feature, or is this basically just the point cloud file format? Can you maybe just elaborate on that? While we wait for the follow-up question, guys, please feel free. You're more than welcome to unmute yourself or raise your hand, and then I'll attend to you. So please feel free. If you've got any questions now, just raise your hand and I'll attend to you. I see Noslaku. Yes, you can unmute yourself.
Hi. I just want to understand, because the main objective of this project was to generate a flat line. So I just want to know, how was the flat line generated using all this data that was captured?
So Nhlako, ultimately what happened was, it was for us basically just to, it was a project that came up. So ultimately what Regiomatics did, they basically used the GPS points, and they've delivered that as a deliverable. The data, the drone data was purely just basically for comparison purposes, but we are making the deliverables, which is the point cloud and also the orthophoto. We're making that available to them so that they can use it for future projects. But ultimately what they could have done is to use the point cloud data after the analysis. You can combine the data where the problem areas were basically close to the dams, where there was high vegetation and long grass, where the accuracy wasn't satisfactory. You can replace that with GPS points and then ultimately use that as the final deliverable. So, but to answer your question, the final deliverable here was Regiomatics, because they did that survey. The project already, they were appointed in late December already, so they needed to submit the data before we actually went to the site to fly it.
Okay, thanks. I'd also like to know the cost. If we were to do this project using a drone, how would it cost less compared to doing it with a GPS?
Well, in Nhlako, yes, definitely that is the case, because the thing is, and the reason why I'm saying this is that the majority of the project, depending on the type of site that you're actually flying in, if you're thinking about a typical construction site, you could have flown that area with confidence, right? Because the thing is, depending on obviously all the stuff that needs to be in place, like your ground controls, etc., there's a lot of construction companies and mines that's only using drones for data capturing now. So ultimately, yes, depending on your site, if you think about this specific site, there was areas, the bigger areas, so ultimately, you will see when I overlay the data now on top of each other, we covered a wider area. So you actually generated more points. Yes, you have to just fill in with your GPS measurements in some areas, but ultimately the data can be combined to ultimately, and also it's a better service delivery, or the final deliverable gives for a better experience for the user, for the end user, which is the client, where you can now basically have the visuals and have more points of a better digital terrain model of the area. I hope that basically answers your question.
Thank you.
All right, guys, my apologies. We are running a little bit over. So please bear with me. You're more than welcome to jump off the meeting if you've got other responsibilities. We're just going to stay on for about 3 to 4 minutes onwards. Also, if you're interested, there is a link that was shared in the chat box. If I can maybe just ask my colleagues just to help, just to reshare that, please. If you have any questions and you would like to know more about this, please feel free, log on and we'll make contact with you. I'm just going to open up to Alan Brown, TBC versus Pix4D mapper briefly, please. Alan, what is, and here I'm just going to basically say from a Trimble Business Center perspective, is that once again, it's your geospatial data hub. This is the software platform where you can put various sensors. So if you're doing survey and mapping applications, I mean, this is now where you can put your GPS data and your drone data together to ultimately not jump between software packages. So to be biased, that would be my response to your question there. All right.
Fantastic. Thanks a lot. Just a quick one. I mean, with Pix4D Mapper, you put in your GCP coordinates as well, and you process it in that manner. So it's very similar to TBC, or am I wrong with that?
Yeah, no, you're 100% correct there. So ultimately, the process is exactly the same. What is good is that, you know, as I've mentioned with TBC, you set up your project settings. Yes, you can do that in Pix4D Mapper as well. But the bigger picture is if you had other survey data and you want to have everything in one project, in one software suite, that is really where I would say where TBC's got the upper hand. I'm going to quickly hand over to Conrad. Conrad, maybe just briefly elaborate on that questions, maybe parts that I might have missed just from a user experience maybe?
So yeah, like Gustav said, TBC is basically your field to finish workflow. You can work with your data once it's processed and you've got your deliverables. You can use it in TBC and just all in one place. Pix4D, it's very nice. You can, but with Pix4D, you have to then use Pix4D for the processing part, and then once you get your deliverables, you have to then pull it into your third party, like your survey program that you use. But they're both very effective programs.
Right, and I think also, yes, Mohsen from Trimble actually replied in the chat box as well. There was a dedicated photogrammetry, a TBC photogrammetry module webinar that Mohsen from Trimble, and Mohsen, very welcome to the webinar. He shared the link to that recording. Guys, please feel free if you want to, if you're basically in the stage of deciding between software packages, I would really urge you to go and have a look at that webinar. The link is shared in the chat box. There was a question on minimum computer characteristics. So I'm just going to quickly share this PDF document, which I will share with you guys. But this is just a quick brief overview of what the system recommendations are. These days, because of working with large data, it is advised that you are focusing to try and get as close to a 32 gig of RAM at least. So this is just a quick overview of that. I'm just going to see if I'm going to upload that to the chat box. It's a PDF document. If I can't get that done, please just put your details down in the link, and then what I will do is basically reach out to you and send the PDF documentation to you. Okay. Any other questions, guys, before we conclude the webinar? My apologies for running slightly over, but thank you for interacting. Thank you for just I see there's another questions from Gatsikai. Gatsikai, yes, how can I help you?
Okay, thank you. I wanted to ask when you use this model or this type of drone after processing your data, I wanted to ask, I had an experience with one of the models, not DJI, but I wanted to ask if you compare your DTM, where the one you use with the drone after processing, and the one points you pick, let's say you pick common features, maybe brake lines or maybe a tower points, whatsoever it is, and compare the elevations. How were they in relation to
to the data which you got from the drone? The one you get with the DGPS, the one
Yeah.
yeah.
Yeah, so we got very good results there between the 3 to 5 centimeters in certain areas where there wasn't long grass areas. So Gatsukai, that was during the TBC process, those area with that magenta colored areas. And I would like to take this, just basically show you the experience, maybe just to show you the type of results that we got. Maybe if you can also just fill in the link, just fill in your information there, then I can spend some time just to take you through that process. But we managed in certain areas, as I've mentioned, because of the challenges on site, we got good results in the specific areas that I've highlighted. All right, guys, that's basically a wrap. Conrad, thank you so much. Thank you for joining me on this webinar. To all the attendees, guys, thank you so much for participating and registering for this webinar. If you have any questions, as I've mentioned, please make use of the link, fill in your details, and we'll definitely reach out to you guys. We've got some sample data sets as well. The idea is then, if you're interested, let's take you through the journey where you can basically now use the sample data set. We'll share a dedicated workflow with you. Basically, we'll take you on this journey of taking the raw imagery and then creating that into deliverable. So that's ultimately the idea, that we want you to, just for the newcomers, the new guys that's still kind of, a little bit, don't trust, how do you do the data caption process? Is it difficult? Give it a go. I urge you to give it a go. Let's basically take you on this journey. It's definitely a tool that you can use to get to basically be better, to deliver more, and also make that basically the sharing of the data and the appreciation of the data a much more pleasant one, and also getting the best out of your data in a nutshell. Right, that basically concludes the webinar. As I've mentioned, guys, the recording will be available. To have a look at the recording, you can just go to our website. I just want to lastly show the last part of the is to also make use of our social media platforms. Reach out to us, go and have a look at just to come back to that point. You can go to our Optron website, go to webinars, all the recordings will be available there. So hope to see some of you guys again soon, and I thank you for attending, and see you at the next webinar. Thanks, guys.